Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem binary tree preorder traversal. In this problem, we are given with a root of a binary tree and we have to return the preorder traversal of its nodes values. So let us take a look at the example. Before examples, what is meant by preorder traversal? Preorder traversal is a way of traversing a binary tree where we first visit the root node and then traverse its left subtree and then its right subtree. So what is preorder traversal? Preorder traversal is a way of traversal where first we visit the root node and then we visit the left subtree and then the right subtree. So in this case, firstly we have root as 1. So 1 is added to preorder and then we don't have any left to it, so we directly come to right. Here we have right, so first right's root and then we go to its left is 3. So 3, we recursively try to go to 3's left. 3 doesn't have any left or right, so we move back to 2 and try to traverse its right. So it doesn't have right as well, so our preorder traversal will be 1, 2 and 3. And next we consider the null root. If we have root node with null value, so like the tree has no nodes, then we directly return empty list. If the tree has only one node, then we return that node itself. Let us understand with a better example. So let me bring up the whiteboard. So in this case, we have this tree. And so first, this is our root value. So firstly, we are at root. So we add 1 to preorder and then we move to its left subtree. So we print left subtree's root and then we move to its left. Now the left is, we come to left and now we are at 4. We print 4 and we try to go to its left. It doesn't have any left, so now we come to right. It doesn't have any right as well. So we come back to 2's right. 2's right. 2's right is 5. So we print 5 and we try to go to 5's left. It doesn't have any left. So now we come to right. It doesn't have right as well. So now we go to 1's right. 1's right is 3. We print 3 and we go to its right. So its right, its left is 6. And now we again try to go to 6 left. It doesn't have any left and it doesn't have the right as well. So we move back to 3's right now. 3's right is 7. 7 doesn't have left or right value. So this will be the preorder traversal of our binary tree. So what we did here, first we are at root, we print the root and then we recursively go to the left subtree, and then after completing traversing the left subtree, then we move to root's right subtree and we again recursively traverse the right subtree. So let us code it up. Let us code up the recursive solution. Here first we have to consider a list of integers preorder. This will be a array list. And now let's have a helper function where we calculate the preorder. Let's say it as preorder helper. We pass root and preorder list. And finally, we return the preorder list. And here we have, let's implement the helper function private. It doesn't return anything, so void preorder helper. The first argument is root and the second argument is list of, this should be tree node, right? Or integer, it should be integer only. So integer preorder And so firstly, we check if root is null. If root is null, we do not do anything, we just directly return, or else we add the root value to our preorder. Preorder dot add root dot value. And then what we do, we recursively first go through the left subtree. So preorder helper root dot left comma preorder. And now after completing left, we go to the right subtree. So root dot right comma preorder. So this looks good. Let us run it. It passes all the sample test cases. Let us submit it. So it got submitted. So this is a recursive way of solving the problem. What is the time complexity of this approach? Since we are iterating over all the nodes in the tree, the time complexity of this approach will be O of n, where n equal to the number of nodes in a subtree or in a tree, in a binary tree. And what will be the space complexity? The space complexity will be O of h, because here we are implicitly using the recursion call stack, where the call stack length would be the height of the binary tree. So this is the recursive way of solving it. Sometimes in the interviewer might ask you to solve this iteratively. So you have to solve it iteratively as well. You have to mimic this recursive solution using the stack. Using the stack and building an iterative solution. Let us see how we can do this. Let us discuss that solution as well. So let me erase this. Erase all of this. Okay. So firstly, in iterative solution, we should have a stack because we are trying to mimic the recursive solution. So in recursive solution, we have a implicit call stack. So we don't have to use anything to keep track of what are the nodes that we have visited so far. But in the case of iteration, we should have a way to keep track of what are all the nodes that we have visited so far. We keep a stack. So now what we do, let me use another ink. So first we are at root node. So we first push the root node into our stack. What we do first, we push root node into our stack and then we loop. We have to do traversal, right? So we loop and first we print root value or add root value to our, we pop from stack and print the root value. And now we go to roots right and push it into the stack, push roots right, and then we push roots left. Why? We will see in a moment why we do right and then left, because in preorder first we traverse the left subtree and right subtree, but here we are pushing right and then we are pushing left. Why? We will see in a moment. So first we push root into our stack and now we pop one value and we print it, pop and print. And now what we have here, we pop print root, then we push roots right. What is roots right? 3 is roots right. So we push 3 into our stack and then roots right. We push roots right, then we push roots left. Roots left is 2. Why we do here like this? Because stack is a last in first out data structure. So if we push 2 and 3, then what we get on top, we get 3 on top, and then we loop again and we pop and print the root. So here we print 3. 1 3 is not correct to pre-order traversal. If we push 3 and then 2, we remove top and we print it in our pre-order traversal. So this is our correct pre-order traversal. Since stack is a last in first out data structure, we push 2 at last so we can get it first. I hope you have understood this. So we pop 2 and we print 2 and we go to its left subtree. First we go to right? So we go to its right subtree and we push 5, and then we push its left 4, and now we pop again. We pop the top, we print it, and it doesn't have any right or its left. So we go back and we pop 5 from the stack, and 5 also doesn't have right or left. So we pop 3, we print 3, and it has right. So we push 7 into stack, and then we push its left 6. Now we pop top of the stack, we print it, and we try to go its right and its left. It doesn't have right and left. So again we pop from the stack 7, and it is also a leaf node, so it doesn't have left and right. So finally this will be our pre-order traversal. What we did here, initially we initialized a stack, then we pushed root node into our stack, then we started a loop. In loop, first we pop the top of the stack and we print it, and then we push the right node, and then we push the left node, and we looped it until the stack is empty. Until the stack is empty, we have continue doing these operations. So this is the iterative way of solving it. So let us look at the code. So here we remove this, and we have to first initialize the stack. Stack will have 3 nodes. STK equal to mu stack of 3. Let's keep it simple. And now what we do initially, we push the node. We push the root node into our stack. Next we loop until the stack is empty. So first what we do, we pop the node, we pop the top of the stack. So let's say it as current node stack dot pop, and we should know in this case, if root value is null, we push null value into the stack, right? So we have to check if current node is equal to null, then we return, then we just break the loop, and if it's not null, we have to push it into our, we have to add it into our pre-order dot value. And next what we do, we push the right subtree. So if current node dot right is not equal to null, then we push it to our stack, current node dot right. And again here, now after traversing right, after pushing right, we push left. If left is not equal to null, then we push right node, left node. If left is not equal to null, then we push left node. Finally, we return the pre-order traversal. So let us run this. Semicolon. We passed the sample test cases. Let us submit it. It passed. So what are we doing here? Firstly, we are initializing the stack. Then initially we are pushing the root node into our stack, and we are running a loop until our stack is empty. We are popping the top of the stack and we are checking if it's not null. If it's null, we are breaking out of the loop. If it's not null, we are adding it to our preorder traversal. And then first we push the right node and then we push the left node. Why we do this way? Because stack is a last in first out data structure. Since we want we want to traverse left subtree first, we put left subtree last into our stack because we can pop it first. Finally, we return the preorder traversal. What will be the time complexity? This loop will run for all the nodes in our subtree, so the time complexity will stay O of n, and the space complexity would be O of n as well, because the stack can contain all the nodes. So this is it for today. I hope you have understood both the recursive and iterative solutions. If you did, make sure you hit that like button and subscribe for more daily videos. Keep practicing, and thanks for watching. Bye.